everyone, now I'm here with my next video of nested loop in which I want to consider one number, that is automorphic number. Now let's see what is automorphic number. An automorphic number is a number whose square ends in the last same digit as the number itself. See, for example, if I am taking 5, the square of 5 is 25 and 25 ends with 5. And now see, 6. Square of 6 is 36 and 36 ends with 6. Square of 76 is 5776 and it ends with 76. And so on we are having so few numbers. They are automorphic numbers. Now moving further, how we are going to create a logic of automorphic number first of all, and few automorphic numbers by squaring. I'm showing it. 5, that becomes 25. In last we are having 5. 6, squaring of 6 is 36 and in last we are getting 6. 25, square of 25 is 625. In last we are getting 25. 376, when we square we are getting value and in last what we are getting 376. In this you are able to understand what we have to do. First of all, we have to count how many digits we are having in our given number. In the same number of digits, we have to pick from here. If it is 1, we have to pick one digit from last. If it is 1, we have to pick one digit from last. If it is 2, then we have to pick last 2 digits. And if it is 3, then we have to pick last 3 digits number. First of all, our target is to count the number of digits and we have to pick the number of digits from here. How we are going to pick it? We have to focus it. Number 1, what we have to focus? Number 1, we have to count digits. In number 2, what we have to focus? How we are going to pick digits from last. In this way you have to check. Having our counting of digits and how we are picking digits from the last. Now we have to focus how we have to count. I had created logic to count number of digits. In this way we can count. First of all, I'm using while loop because I don't know how many digits a number is having. That's why I'm keeping while loop, because while loop is unfixed loop. In what I'm doing, I'm counting it and I'm rotating the loop again and again. How? See, first of all, number is 456 and I want to rotate this loop again and again till I'm getting 0. How? See, I'm dividing a number by 10 and storing whatever I'm getting as quotient again in my number. This thing I'm doing again and again. See, in this way, it is the first count and again I'm doing the same thing. I'm storing my quotient, whatever quotient I'm getting, I'm storing it in my number. Whatever quotient I'm getting, I'm storing it in my number. The same thing, second count, I'm doing again and again. It is third count till our quotient becomes a number and a number becomes 0. Till I am doing all these things again and again, and here I am doing the counting of number of digits. See, the counting raised by 1 1 till 3 times I'm doing the same process. Num is greater than 0. Yes, I'm dividing it and storing what I'm getting as quotient. I'm storing in the number and again I'm checking my number is greater than 0 or not. 45 is greater than 0. Yes. Again I'm raising my counting and see, number divide by 10, what I'm getting now 4. It becomes 4. Now 4 is greater than 0 or not? Yes, it is greater than 0. Then count increases. See, the count increases. And now what I'm getting questioned, that is 0. I'm storing 0 in my number. And now 0 is greater than 0. No. Means whatever counting we are getting in last, the number of digits is whatever count we are having with us. That is number of digits. If I want to pick the number of digits from the last, I told you in my previous slide, we have to pick some numbers from the last. How we are going to pick digits from last? If you want to pick for one digit only, then go with mod 10. If you want to pick 2 digit, then go with mod 100. If you want to pick 3 digit, then go with 1000. In this way, you can raise your numbers one by one. Means, see, for picking the last digit, we want 10. If I'm having a number that is 456 and I want to pick 56, then what I have to do? I have to divide it with 100. What I am getting in last, that is 56. Means for picking 2 digit, I have to use 100. For picking 3 digit, what I want to use? I'm using 1000 here. Then I am getting, see, the last 3 digit I am getting with the help of 1000. In this way, we can pick our digits from the last. Now see how we are going to create our logic. What we have to do? I told you we have to do the counting of a given number. That's why we are having count with us. For rotation of the number again and again, we are having while loop. Now what? In last, what we are getting? Num becomes 0 because one time it becomes 45, another time it becomes 4, another time it becomes 0. That's why we have to store a num in a particular variable. And because our target is we have to square a given number, what we are getting we have to store in a particular number. That's why I'm squaring my number and I'm storing it in SQ. Now, what I have to do? I had done my counting in count. I'd square that number and store in 25. I had done that task. Now my task is to achieve the last digits. I told you to pick only one digit. We have to use mod 10. If we want to pick 2 digit, then we have to use 100. If 3, then 1000 and so on. Now what I have to do? The same thing. I had done my counting. That's why I'm writing math.power 10 to the power count, because I can write 10 as 10 to the power 1, 100 as 10 to the power 2, 1000 as 10 to the power 3, and 1, 2, 3. 10 to the power 1, 10 to the power 2, 10 to the power 3. These 1, 2, 3 were the countings. That's why I've written 10 to the power count. What I'm getting, I'm storing it here because power always written values in decimal. That's why I want integer part only, not the decimal part. That's why I'm writing int here. I'm having my square, that is 25. I want to pick the last digit because count is 1. That's why 10 to the power 1. What I'm getting here as last digit, that is 5. I have to check my last digit with my original number. If both the numbers were same, it is automorphic number, else it is not an automorphic number. This is the logic of automorphic number. Now, I am rotating something by creating a new thing. Now, I want only numbers, those are composite automorphic number. I had already given you the logic of automorphic. I had previously told you what is composite. Now I want the composite automorphic numbers between a particular range. Now how I'm going to do this? I told you what is prime and composite. Again I'm telling you, if we are taking a number 5, we have to check how many factors 5 is having. If factors were 2 or 5, now I'm taking 6. We have to count the factors. Factor of 5 is 2. Factors of 6 is 4. And prime is the number whose factors were 2. And composites are the numbers, those who are having more than 2 factors. And our target is to find composite number. I told you the logic of composite already. We have to find the loop from 1 to that number, whatever I'm having. I have to find the factors. And if the factors were 2, it is prime number. If it is more, then it is composite. Now I'm moving towards the question. What I want? Composite automorphic numbers between a given range. Range is between m and n. Condition should be mentioned where m should be smaller than n, m and n both were greater than 0. And I want to count my frequency of the composite automorphic numbers. Frequency means how many times we are getting composite automorphic number in a given series. Whatever range we are having, how many numbers we are getting in between those range, we have to find that. Now moving further, see what happened. Composite automorphic number, because we have to accept the range, the limits, that's why I'm writing import java.io. Asterisk. You can use scanner also. Here you have to use java.util if you want to use scanner. Then see, I'm accepting all these things. These are the common things what we are writing. We have to accept the limits. That's why we are accepting limits here. Now we have to check whether our limit m should be smaller than n and m should be greater than 0 and n should be greater than 0. If they are providing a exact limit, then we are moving further. Where we are moving further? To find the composite automorphic numbers. Now, between the range from m to n. Now what we have to do? I provide us a number. If I'm taking value that is m is 10, n is 50. Means value of I starts from 10, end on 15. I always increase 1 by 1 till I equals to 15. That's why I'm storing my I as a number in num. Because I is having another task also for increasing it 1 by 1. That's why I'm storing I in num, because whatever task we have to do with that number, we will do with num. We are not supposed to change our I, because I have to change itself again and again. That's why don't try to use I. Store I in somewhere and use that number. Now what I have to do? See, here, what we are checking? The composite number. I already provide you the logic. We have to have a particular loop for composite also. Means here we are using nested loop, loop inside loop, that is nested loop. Here we are having a logic of composite. Means from 1 to that number, we have to check number 1 by 1. And what we are getting as factors, we have to count them. And if factor is not equals to 2, means it should be greater than 2. And that's why we are getting composite number. It is the logic of composite number. Now, what we have to check? If a number is composite, then we have to check whether it is automorphic or not. If a number is composite automorphic, then we have to display our number. See, If it is composite, then I'm putting the logic of automorphic. I'm saving my number again in P, squaring it and storing it in SQ. I'm counting it, how many digits we are having, and then I'm picking last digit, and then I'm checking my last digit is equals to my number or not. If it is, then I'm displaying my number. I can write P here, I can write I here, both were same. And see, I'm displaying my number one by one in this way, 5, then 6, and so on. And then here I'm counting how many numbers I'm getting, that is composite as well as automorphic. I'm counting them, and when I'm getting over with my task, means I had done my automorphic logic also, I had done my composite logic also, means it is completed, and done my loop also. Loop is also done, and then I want to check whether the frequency is 0 or not, because I had completed my counting from 10 to 15. Now I want to check whatever number I'm getting or not. If I'm getting nothing as frequency, means I'm not getting any number, then I want to display not found. Means in that range we are not having any of the number that is composite automorphic. And if we are getting, then I want to display the frequency, how many numbers I'm getting between these frequency. And I had done my condition work also. Whatever condition I'm writing here, see here, I had closed that curly braces here. If condition is not proper, then means range is not proper, then I have to display it as invalid range. Then other two curly braces were of main and class. Now see what happened. If I'm providing the two limits as my output, 10 and 100, what I'm getting as composite automorphic numbers, that is 25 and 76. The frequency were 2. Again I'm running it, and what I'm getting, I'm entering two numbers, that is 10 and 1000. What I'm getting as my output, 25, 76, 376 and 625, means 4 composite automorphic numbers. Means what are the frequency? 4 numbers. In this way you can have any sort of numbers. Either you are getting any of the two numbers, and I'm telling you, you have to check first number and then you have to check second number. If both of the number were present, then only you have to display. In this way you are getting your questions also. Do practice the question in this manner also, even in switch case, in this way also. Try to do that. If you have any doubt, do consult with me. Otherwise, goodbye and good luck.